right. So our speaker today, our presenter today is going to be Jared Mayo. Jared is a business development and key account manager for BUCHI Corporation. He's a Keldol expert and specializes in applications, technology, and support for all industries, including chemical, pharmaceutical, food, feed, beverage, and environmental testing. So Jared, I'm going to go ahead and hand it over to you. He's got the slides running, and thank you all for joining us today.
Thank you. Yes, good afternoon. Everyone, thanks again for joining us. This is meant to be brief and informative. We're really going to talk about the chemistry and the workflow here, and we will have a chance for Q&A here at the end. So let's get started. So the agenda today, again, we're covering TKN determination based off the compliance needed to run this here in the United States. So we're going to do a brief introduction into what we're going to discuss. The equipment that's being used in this particular workflow, which is automated TKN analysis in wastewater. The procedure, so we are going to go step by step as to what's being done, the chemicals being used. Really we're going to be following an application note that we developed where we're going to go step by step within the experimental process. The results that we've seen from this particular test run, how it relates to the compliances that you're following. You can see the standard methods booklet there, the image there on the left, and everything you're going to see today is completely compliant with 40 CFR part 136.3. So that's really going to be a driving force with today's presentation. Some conclusion as to, everything we discussed and again, how automated Keldol may compare to some other things and how effective it is, the resources that are available, and lastly, like I mentioned, Q&A session. So let's get going. Really what we want to start, and I think if you work in the lab or manage your lab or you work in an environment where there's testing being done, we as application scientists or as manufacturers of equipment can't really tell you what to do without you having some self-reflection. And so that's really the key word. We want you to understand, okay, what is our sample throughput, and think not just now, but self-reflect on what your lab may look like here in the future, because that could really determine what is needed from not only kind of your core equipment standpoint, but the accessories, the testing methods, potential other methods that you may be running in the future, and so on. The sample type, the difference between solid and liquid samples. I know today we're kind of focusing on wastewater, but are you looking at sludge? Are you looking at solid waste? Are you a multi-dimensional lab where you're also testing food products or agricultural products? What your current methodology is, if you're running, let's say, like a hop kit, or you're running manual Keldol, or you're not running it at all. The exact type of test that you're running, whether it's just TKN and ammonia, whether you're looking into speciation and selective nitrogen like nitrates and nitrites, and you want to be able to determine each one. These are all things that will help us as kind of consultants and manufacturers to make sure that we meet the total demand of your lab, and then likely the titration aspect of it. So we have options for, or really just in general throughout the market, there's options for it being completely seamless with automated titration, working hand in hand with distillation. With you kind of more old school, taking the distillate, running it to the titration separately, manually doing it, which I'm sure is very time consuming. Hopefully no one's manually titrating today, but so that's what we want to look at. The last kind of key piece that's not really on here is the recordability and some of the compliance aspects. What level of compliance do you need to meet? How much is data recording integration into your LIMS system? How important is that today, or would that be important a year or two from now? So again, when you're looking into whether or not automated Keldol or really any of this technology is really a good fit, there needs to be a lot of self-reflection done beforehand to fully understand maybe what your capacity is. All right, so For the equipment, this specific application note that again we is from a real life, us running TKN samples. We're using our block digester, so kind of as what's stated within standard methods. So we're using block digestion as well as a scrubber. The scrubber is basically going to pull any of your acidic vapors, neutralize them. There's also some charcoal in there for some absorption and then condensation as well. So we're going to completely condense and neutralize all vapors, which means that your fume hood will not be dissolved away and damaged. So that is another key point of this. And then typically this is a common workflow. We move from this block digester, which has a 20 position rack, and we can transfer that rack directly onto an auto sampler. In this case, we have a 24 and a 48. I believe for the application note, we were just using the 24, but it all works the same. And with what BUCHI calls our K through 75, which is basically your all-in-one total Keldol suite, which has a distillation directly into titration, so completely seamless, and that's what we're using in the application note today. Another common workflow we see is using an IR digester, which is instead of using a heating block, it's just using an infrared heating element. In this particular case, this one can hold 12 positions, but we also have some for 6, or you can use really anywhere between 1 to 12. So it's a lot more flexible. It's a lot better fit for smaller labs, unless you have a certain SOP or compliance that needs to run a block digestion. Again, working with the same scrubber, and then going into what we really call our semi-automated Keldol. So this particular unit, it's completely modular. So it's really, really nice for labs that are growing. Maybe you have only a few TKN samples a week, and you don't really need a full auto sampler or a large suite. There are options like this available where you can still load a sample and walk away and rest assured that it's going to distill and titrate and get you those results quickly and easily. But it doesn't really have the same sort of financial investment as something that, if you're running a really, really high throughput of effluent water and wastewater. So you can always mix and match, but these are some pretty common workflows. Really, the moral of the story is that in the market as a whole, when it comes to Keldol, there's options for a few samples, some options for a ton of samples, and really everything in between, especially as, 1 week you might run 2, one next week you might run 20. There's really something that can really work perfectly for every single different lab situation. So here's a little video. It's really about 60, 70 seconds. What this is showing is the fully automated suite. As you can see on the interface there, the system's running, it's preheating, it's kind of running its initial diagnosis. You're loading the rack. In this case, there is no sample transfer at all, which means your techs or you yourself would not have to touch any glass tubes, nor would you have to transfer samples. So there's zero tube movement, reduces error for glass breakages. It's going to transfer the sample via steam distillation. So there's also no physical movement of the tubes, or also the automation is really done through that tube, which means that there's no risk for damage, the tube kind of reaching down and breaking anything or becoming clogged. It's distilling directly into the system, and then it's going to run its titration, run a cleaning cycle, and then move to the next. So as you can see, one of the racks was just removed and then replaced. So in this particular setup with a 48 position, you're able to load 24 samples, change the rack, load 24 more, and you can continuously run this for a long time. So again, internal reflection. Hey, is my lab or my organization something that needs to run, 100 plus samples a day? If that answer is yes, this is probably a very nice, valuable tool for you. If not, maybe not really the best fit, but just something very nice that's offered to really kind of meet any demand that may become available. So within the procedure, so this is your common TKN workflow. I'm sure we're all familiar. Your digestion to your alkalization, the distillation, finally the titration, and then we have our value. So pretty straightforward. So first we're going to start with digestion, adding your acid, adding your catalyst, and then, doing the digestion, heating it. And like I said, either a block or your IR, or if you're running it manually, potentially like a heating mantle or heating plate. I did want to touch a little bit more specifically onto the catalyst. So historically, mercury and selenium were common. Now with the toxicity that we know, it's become a lot less common. And you would need special disposal and things like that. Now today, there's a lot more economically friendly options that we have for both copper and titanium based catalysts. As you can see, some of the advantages and disadvantages. We like to always recommend our titanium tablets. This particular composition, it is a little bit of BUCHI proprietary, where our Missouri is pretty much the same sort of catalyst that you would see in most manufacturers and things like that. With the titanium, we do have a little bit of titanium oxide that's in there. That's going to really help break down a lot of organic and fat matter. So if you're a lab that sees a lot of different things and you're not sure what sort of oil, fat content, grease content, or other types of organic materials may be passing through your water, the titanium tablet or catalyst is an excellent tool because it will kind of catch everything and it's not going to impact any digestions where maybe you have less than that. The Missouri is, let's say you are a chemical manufacturing plant and you just have to run your own effluent water, and the water that you run is pretty much consistently the same thing every single day. You probably maybe don't need titanium. Perhaps Missouri or even Eco would be a lot more sustainable for you. And so really the moral of the story here is that there are newer types of catalysts that have a lot lower toxicity, but you don't sacrifice any of the sort of digestion efficacy, and that there's different ones that can accommodate varying organic material composition. So moving on from there. So this is the exact experimental workflow that we ran. This the test method that we were running. Really, the only thing of note, and really, we designed this presentation for you to come and revisit. So don't feel like you need to read every single line. When this is shared, or we can also provide this information directly to you. You can go through and really see and read this more specifically. If you're looking for a recommendation, you're looking for an example SOP to follow. But really, the only thing that I would note is you can see as your volume increases there on the right side under section 4.2, your digestion time is going to increase. So I'm sure that makes sense for most of us, but just wanted to make sure that that is in there. So the more you dilute, obviously, the longer that you're running your digestion, just by nature of the physics. And I will also note that in this particular application, we did use the titanium tablets, as you can see written in some of the text. So after digestion, you transfer your rack or transfer your tube depending on your workflow, and we're going to be working with the alkalization and then the distillation. So you can see basically what that looks like on the K375, which is the example equipment we're using for this particular method. Pretty straightforward there. And then going a little bit deeper onto the titration. So again, I know we all took high school chemistry or college chemistry, so this is something that we're all familiar with, but just know that the technology within our instrument, and again, this is common throughout the market, is going to be performing all these calculations for you in the case of automated Keldol. So no more handwritten calculations. All this will be calculated for you, and it could be upgraded or uploaded into your LIMS system, or however you have your instrument wired into your organization's internet. So just like the digestion, here's a little bit deeper into the distillation. You can see the exact parameters that were used in this particular case, titrating with boric acid as a standard. I will note that we are actually using a potentiometric sensor. So we're using a pH probe, and that's just because, we're all familiar with pH probes. Most labs, typically always have one. This option is also available in colorimetric. So we do have both, and we also do have application notes that go step by step like this for colorimetric as well. We just found that potentiometric is very easy, and you don't have to use indicators or anything like that to run it. And so that's what this is running on. And you can see on the right the calculation that I referenced before. But again, you can always come back to this and look at it as this is shared following the end of the webinar. And then some of the results. Really, the main takeaway, I know what's most important when it comes to the testing perspective is we're looking at the limit of detection and limit of quantification. So you can see those numbers there on the bottom right. So the really nice thing about Keldol and this really traditional form of chemistry is that we're able to achieve very, very high your limits of detection. So if you're familiar with, if you're using a more manual method, or like I say, you're using like dye kits or hot kits or something like that, your reliability, dependability, and also your limits of detection are probably not going to be as great. So this gives you a lot more trust, but it also allows you to catch a lot more TKN if you're running, extremely low quantities, parts per billion and things like that. So here's some other results. These were just using stock solutions, not really a whole lot to touch on there. Just wanted to make sure all the information was available. Two more stock solutions. So we're running a 25, 50, 100, and lastly a 200 mil, just stock solution of urea, just to form a baseline. And then lastly, here's two different results. So we have two different bodies of water. The results that were achieved. Again, you'll be able to take a look at these, but these are the results. So compliance, and then again, this was something that we really wanted to focus on for this presentation. I feel like we're all pretty familiar with the workflow of Keldol, but can I use this? Is it compliant? How does it work with our internal workflows, our internal regulatory commitments? So like I said, this whole application note was really made to show the compliancy within 40 CFR Part 136.3 and standard methods, specifically 4500. So on the table on the right, you can see the first column, the application note, as far as what we did. So this summarizes everything that I just went through today from, hey, we're using potentiometric titration. We alkalize with sodium hydroxide, of course, at 40 mils. We only distilled with or diluted with 50 mils of water, which compared to some other methods, you may be diluting much higher content. So using an automated Keldol workflow like the one we discussed today, you're using far less water, which means your digestion is also going to be a lot faster, and your distillation will be quicker as well because you have less volume. And you can see the tablets, the catalyst that we use, and basically how everything compares to standard methods, and also the ISO method as well. So I'll just let you guys kind of take a look at that. I know this is an important slide. And again, I know I said it a few times, you will be able to come back and look at this more closely. I'm also happy to answer questions here at the end. Oh, sorry about that, went backwards. So in conclusion, we were able to provide, really great, reliable, and reproducible results using an automated Keldol setup. The limited detection was 0.014 mg per liter, and the LOQ is 0.21 milligrams per liter for about a 200 ml sample is what we used on the actual body of water examples, not the stock solution. And again, this is something that's completely compliant with standard methods 4500. And really another big takeaway, as it talks about, you're able to run all these samples without really being in front of the instrument. You can load your rack, walk away, go to lunch, run any other experiment, prep methods, anything that you need to do. So it really frees up a lot of time for something that's a pretty relatively simple. This is something that anyone in your lab could really do. You don't have to have a whole lot of expertise to run automated Keldol in any way. So it really frees up your personnel, helps you maintain an efficient laboratory running these sort of methods. And again, wanted to reiterate the self-reflection. So after knowing everything we talked about, seeing the workflow a little bit more in depth, thinking, okay, what is my current, sample demand? What is our sample demand looking forward into the future? And what does all that look like? And now maybe you have an idea of maybe what equipment could work best for that, whether you're doing Keldol currently or doing a different method, or not doing it at all, maybe sending it off. So the resources, we have some really, really excellent resources. So the first thing on the top left is our BUCHI knowledge base guidebook. This is an extensive electronic guidebook where you can click different links. There's, again, more examples of actual test methods, real life examples where we're able to really provide a lot of really great consultative information to you. Various chemicals, the actual chemistry of what's being done, so you can really optimize it, as well as our proficiency guide. And then again, we have these application notes like the one we kind of used today to guide the webinar for TKN and ammonia within wastewater, potentiometric, colorimetric. We also have digestion, specific application notes for things like COD. We have aqua regia application notes. We have selective nitrogen application notes, testing specifically for nitrate and nitrite, and lots of others that involve even other methods such as concentrations, extractions, things like that. So just know that there is an entire application library that's available. So if you're ever looking to explore optimizing a method, adding something to your lab you're not currently doing, whatever it may be, automating something, just know that there are resources available to help make that decision easier for you. Lastly, the references. So you can see those again. But again, we kind of really wanted to stay true to standard methods in 40 CFR 136.3. And you can see some of the other methods that we referred to in the application note. And that, my friends, is it. Any questions?
All right, thank you, Jared. Anyone on the phone have any questions? I did have a couple that came through. If not, we'll get started with the group here. Okay, I'll go to the ones that came through to me. First one I have here is, how does automated Keldol compare to other methods? So like the hot kits or a flow injection analysis?
Sure. So I mentioned before, when it comes to the reproducibility and the reliability, that's really what it comes down to. Is when you're using binding kits, dye kits, and things like that, you're losing a little bit of that reliability, and also when it comes to solids. And if you're, I apologize, 1 second. So as I was saying, if you have a large sample variability, Keldol is going to really accommodate every different type of sample that could come through. Same thing with flow injection. You're not really going to be able to use solids or anything that has any debris in it. There's a lot of different pumps that can be very easily clogged, a lot of leakage issues. And typically, like I mentioned, with an automated Keldol setup, you're really free to have really anyone available kind of run that. There's not really a whole lot of specificity needed or know-how. When it comes to things like flow injection analysis and discrete analyzers, it's a little bit more of a learning curve. It's a little bit more delicate. So that's what I would say. So in general, I would say within all the different methods you could be running, Keldol is the most robust that you can run. And traditionally, it's kind of the most rugged in that it's pretty difficult to damage. So it's a little bit more kind of safe as far as you're not going to be worried. And it's a little bit more reliable because we're using true chemistry on it. So so I hope that answers the question, but generally that's where we see it fit. And a lot of times when someone's running Keldol, it's typically seen as a workhorse type of method.
Good. So another question that I had that came through here was, says that I think that Keldol uses a lot of chemicals. What's the typical consumable cost?
Sure. Yeah. Good question. I know usually, when people first learn Keldol, then maybe they think about it in the more manual way where we're adding each one of these chemicals by hand, and it can get kind of messy from there. But generally speaking, if we go back to some of the procedure and method, we're digesting with sulfuric acid. which is generally not a high cost consumable. The Catalyst tablets are pretty affordable. I think we sell, it's like a box or so list price of 1,000 tablets for like 845, $850, something like that. So it ends up being like 8 cents a tablet, um, which is pretty affordable for most labs. And then lastly, you're just alkalizing with sodium hydroxide. Again, not a super high cost consumable. One thing that we did develop that's pretty neat, we developed it about a year ago. If not on the fully automated Kildall suite, but when you're just running a few, our semi-automated, so you're kind of running one sample at a time, but you can still, connect with titrator and all that. We actually added something called a reaction detection sensor. So it'll be able to detect when your alkalization has hit basically the total satisfaction needed, and it'll actually cut off the hydroxide. So it'll, traditionally speaking, you would just dose it to excess and make sure everything's completely alkalized. With this, you can actually save even more. So that's something that we had to even save even more consumable costs. But in general, you have your sulfuric acid, the catalyst, which I said are, they're pretty low cost. You have your sodium hydroxide, again, relatively low cost, no really expensive reagents being used, no expensive chemicals being used. And then you have your boric acid, which we also do provide standardized boric acid at both 2 and 4%, as well as some that have the indicators already added if you are performing a colorimetric titration. So.
Perfect. And then I got one more here. So how much time is spent at the instruments and on prep when running these systems?
Sure. So that is the beautiful thing about sort of the workflow that we discussed. This particular one that we talked about today, it's, I mean, very basically not at all. You load your samples into the digestion rack. The block digester itself, you can program methods. So if you're running the same sort of prep method each time, you can just select that, hit go, and it will program the different temperature ramps and times, and you can walk away completely. And then when that's done and you transfer to the auto sampler, you pretty much just pick that up, drop it right in, and then hit the method on the K375, the actual distillation titration unit, and you walk away as well. So, I would say maybe, perhaps 2 to 3 minutes, if that, at the digester. And then really once you load the samples onto the distillation unit, I mean, it's just going to go, and it's going to go until it's complete. So we're talking about very minimal. You don't have to be at the system. It's not like running a Duma or anything like that, where, you have to really keep a close eye and you have to keep track of various consumables and things like that. Um, Loading the sample tubes into the digester is probably going to be the longest time that you'll spend actually running the experiment. You'll be able to walk away, and like I said, you can, go let the dog out, which sounds like I got to do with him barking in the middle of this presentation, or go, like I said, run other different prep methods and things like that. So highly minimal time actually running your samples.
Great. All right. Well, thank you again, everyone, for your time today, and thank you, BUCHI and Jared, for your presentation. We will be sending this out to all of the attendees afterwards, as you mentioned, to give you some time to dig into it. And certainly, if anyone has any questions about any of the products listed today, reach out to your Midland Scientific representative or your BUCHI rep, and we'd be happy to help you. Hope you all have a wonderful rest of your day.
Thanks again. Bye-bye.